Okay, so welcome to our programming meeting. Programming meeting number 2, but it should be number 1 if we're counting from 0, considering the first one is very much a failure. Okay, so let's get started. You'll see that I use the same slide theme as last time because I kind of want to keep a cycle, so you might get some trauma, but it's okay. Programming, the better intro, how to, hopefully not, confuse new programmers. Okay, let's get right into it. So setup. We're actually going to set up a little bit differently this time. I don't want you guys to download anything yet, so if you downloaded it from last time, good job. We'll go over the download setup again in case anyone messed anything up, but we're just going to set up through REPL. I think I have nothing after this. Again, these are very bare bones. So I'm going to start sharing the... I'll just share my actual window. That might be smarter. Wow, I have... Okay, hold up. Let me share my window. And I think the OBS desktop audio works. If it doesn't, that's a bummer. Hold up, I should check that. Yes, okay, I think it does work. And mic looks good too. Okay, just making sure. Don't want to mess up the recording and have to re-record it. I'm gonna share the meeting. Okay, can you guys see my screen, my Chrome? I actually grouped everything in tabs this time, so you guys wouldn't get mad about my 50 plus tabs. Can you guys see the screen? Okay, great. Good news. Maybe. Good for you. Okay. Yeah, so setup is going to be on REPL.it. So REPL.it actually used to be on the domain REPL.it. So if you go to https://REPL://REPL.it, it works. But they reformatted it to replit.com for some reason. Oh no, don't keep me hosting. No, stop. Okay. See, it's really easy to accidentally click on stuff. So we're gonna, if you don't have an account, you can sign up. If you do, then you can log in. I do have an account, so I click the login button, and from here, I have my account set up with my Google thing, so it just automatically logs me in. Wow, look at this, so cool. So your thing is gonna look a little bit more different. Not a little bit, it's gonna look very different. This is just how I created mine. But what you're going to do is, oh, don't mind this. What you're going to do is you're going to create a new REPL. And so for the language, we're using Java, of course, because Java is great and so much fun. So don't do Java Swing, just Java. Let me know when if you guys need help by raising your hand or something. And it'll give an automatic name, but you can rename it. So I'm just going to call this FRC Training. Wow, ain't that positive? And I click Create REPL. You can have a space in the name, I think. I don't know, I don't remember. And it will set everything up, and you'll be introduced to some confusing stuff. So tell me when you guys are at this step, let me know, and we can continue. If anyone gets stuck on anything, just let me know as well. So we're using Replit. Yes, we are using REPL.it. It's fun, it's good, and you guys don't have to download anything, so I don't have to deal with, oh, but my Windows laptop actually can't download that because I need some parent permission. No, you don't need parent permission for this. It's just a website. Unless you have like the website, what is it, blacklisted on your Wi-Fi? That would be a bummer. Okay, so I think that's enough stalling, enough time to get started with doing it. Is anyone still not at the step yet? Thankful because you're on Linux. VS Code is much easier to download on Linux, and the dependencies as well. I got OpenJDK, so it's much easier, to be perfectly honest, on Linux, but whatever. Well, maybe that's your point. Maybe you're not talking with it. Okay, whatever. Regardless, I think that's enough time. Is anyone not on this step? Please raise your hand, because then I can slow things down. Okay. I'm going to assume you guys are on the step, and I will proceed as such. So, once you're here, you're going to see what this is. You can change your tab settings, so if you head over here, you can go to settings. So my current settings are a stacked layout, but your default one might be side by side. I prefer stacked because I like it on the bottom. I like more space to look at my code. You can change the theme. If you go to light theme, then I am officially disgusted by you. You can change your font size. I set it to large so that you guys can easily see it. I know my screen quality is garbage. You can set your indent type and your indent size as well. It doesn't really depend. Make sure you keep code intelligence enabled. It just makes life a lot easier, so definitely suggest that. Okay, Now that we finished that step, let's get back to actually, let's get back to our presentation. So we've set up our REPL.it. Okay, next we're going to talk about a topic that we talked about last time, but I don't think anyone got, primitives. So primitives are basically like the building blocks of everything in Java. So everything is built on primitives. If you want to imagine it, I think a good another sort of easier analogy to understand is Lego. So just imagine these as sort of like Lego blocks. So only the blocks, not the fancy ones with like the gears and stuff. Just very simple Lego blocks. Okay. So we talked about two of them last time, but I'm just going to go over them in detail. So we have Booleans and Chars. So Booleans are the smallest of all the primitives. They take only one binary bit, which is true or false, useful in logic scenarios. So something like if Boolean is true, while Boolean is true, do something, right? So they're actual keywords in Java. We don't know how they work yet, but we might get to it. So that's good news. Next we have our chars, our characters. So characters are the second smallest primitives. They're only 8 binary bits, which means that there are 256 possible characters. They're useful as a literal building block, which means you can attach multiple letters together to form words and sentences. So let's understand how to implement those in REPL.it. So first we're going to delete this line right now. We're not using it yet. So you probably might not even understand it. And let's just get a little bit familiar with our workspace and how we're going to run and use our code. So this is our class. This is basically what all of our code is going inside because everything is supposed to be inside of a class. I didn't fully explain it yet, so don't worry about it. This is also our main function. So when our computer is going to take this file, it's going to look for a main function, and if it finds one, it's going to activate it. Which means if you have two main functions in your code, it's going to cause an issue because you can't have two things that activate automatically. You can only have one thing that activates automatically, which is why it's this one. And the reason why it's formatted as such is because it needs to be formatted in a way that the computer can activate it immediately without having any issues in the middle. Everything okay so far? If you don't understand it, you're not supposed to. It's called Boilerplate Code because it just needs to exist for us to write any code in the middle. It's pretty weird, but that's how Java works. So if you have any questions, you can raise your hands. Don't be afraid to. I'm not going to call you out or anything. And I will call out your name and say like, oh, you have a question? Wow, okay, let me answer it. But it's fine. There's no private chat feature in Google Meets, which makes things unfortunate. Okay, let's continue. So here we have our main class, we have our main function, so you don't really need to understand what those exactly mean. All you need to know is we write our code here. We write our code inside of here, and that's all you need to know. So to make a Boolean, it's pretty simple. You just need to use the keyword Boolean. So this is going to tell Java that we're making a Boolean type object. So we're making a building block, and it's going to be of the type Boolean, which means if you know those Lego, like those 1x1 pieces, really small ones, you can imagine it like that. It's a very small little building block. And so we're going to say we're making a Boolean, and for every single building block we make, we need to give it an identification. And this is so we can go back in our code and say, oh, I was actually looking for these the block that's in this position. So if you take a look at, like, let's say a Lego building, then you want to look for the block that's it's on the third layer and it's right there. An easier way to do that in Java is you just give it a name, and with the name you can find it, or the compiler can find it as well. So is that good so far? We need to give a name to our Boolean. I think by grade 9 they cover variables, so just imagine this as a variable. We're making a variable, and we need to give the variable a type, because that's basically telling Java, oh, look, you need to make a block and it needs to be of this size. So if we make a block that's huge and we say this is a Boolean, that's kind of dumb, because now it's like, oh, what, wasn't I supposed to just make a very simple block? Why am I wasting so much space for this? And the space that it's using up is your RAM, so you don't want it to destroy your dedicated RAM, which is why we typically stick around just trying to use the least amount of space as possible. I don't know if that made sense or not. I hope it did. But yes, we're making a variable, and it's of the type Boolean. That's all you need to know for now. Next, we need to give it an identification. So we're going to say Boolean name. Right? So this is just the name of the Boolean. So we can call this, let's say we were in a scenario where we need to work with robots. We can say alive. So is a robot alive? And then we add the equal to assign a value to it. So you can actually not assign a value to a variable, and it will just become Boolean alive. So it'll just say, oh yeah, we have a block, It's this big, but there's nothing inside the block. It just exists, right? So we can actually keep it empty, or we can give it a value. And so keeping it empty is good if you're going to use it somewhere later in your code, but you want to define it now. But it's good to always give it a value at the start. So we're going to say that it is not alive for now because, you know, who is? And so that's our Boolean alive. So everything good. Do you guys know how to make a Boolean variable at this point? Someone left the meeting. I feel bad for them. What is a Boolean variable? Okay, a Boolean variable is pretty simply, it's just one binary bit. It's either true or false. So it's essentially a building block, and all you're checking inside of it is it filled or is it empty? Right, so is it on or off? Is it true or false? And so it can only have one or true values, which is true or false. And that's, oops, spelled false. And that's essentially all it does. So it's just a variable, and if you're imagining it in math terms, it can either be a 0 or a 1. So it's essentially like x belongs to the domain of either 0 or 1. Again, that's grade 11 math. I don't know if many of you are in grade 11, but that's just, it's either 0 or 1. That's all it is. It's a variable that is either on or off. Okay, I'm going to assume you're good with that. Next, we're going to make our characters. So to make a character, you actually don't write character like this, because that's dumb. So to save space, you write car or char, however you want to pronounce it. And so we'll just call this letter, right? Because that's all it is, it's just a letter. And so to initialize a letter, you actually need to use a special sign. So sometimes, so in terms of these true and false values, they're built into Java. So Java will say, oh, there's a true in your code. True means that this is a Boolean value. And just the same way, it needs to make assumptions about what is a character value. And to do that, we use single quotes and we put one letter on the inside. So let's say we want to make this the first letter of a ball, so just B. Right? So we put a B on the inside, and now we have a letter with one thing. Notice if I put more characters inside of here, it's going to cause an issue, because you can't have multiple things. A character can only be one letter, and it has to be wrapped within single quotes. So it's a variable. We have a mongu here. Yeah, and so a character is any letter. So technically it encompasses, I think, 256 characters, which is the ASCII encoding. So that's about everything we use on our computer. So the English alphabet, all the signs, and all the numbers and everything else, along with a few new line characters. So that's what it encompasses. So it's a few more values in terms of just either true or false. But all you need to think of is it's one letter. So, okay, sounds good. So we've made our first two variables. We've made an alive and we've made a letter, which is cool, but we don't want that yet. We want more. So let's move on to numbers. So numbers, there are two categories to it. We're just going to be talking about integers. So there's the int, the integer. So it's the standard size for most numbers, has 32 binary bits that get turned into a number using some magic formula, which I will very lightly tread on, or very lightly touch on. And so useful for keeping any whole numbers used. So if you're keeping count in your code, like, oh, this button has been pressed this many times, or oh, I have done this many times, or oh, I have moved. No, that's a bad example. Or oh, I have these many cards in my hand, or oh, blah, blah, blah. Right? So it's important for that, and number-based constants. So if you have something like, how many apples does Jim have? Right? And it's like, Jim has 5 apples. Then you want to keep an integer constant, or just a number in your code that says Jim has 5 apples. And so if Jim gets one more apple, then we can acknowledge that within the code. So it's typically just for keeping count, and however else you'd use a number within your code, so for math and other things. And to make an int, it's the same formula as the prior two. I should keep these here. And it's just you use a keyword, which is int here, all in lowercase, right? So one important thing to notice is all primitives are in lowercase. So this is Boolean, it's in lowercase. Char, it's in lowercase. Int, it's in lowercase. We're going to give it an ID. We're going to call this count. And we're going to give it a value. So you don't need any single quotes or anything. Any number will count as an integer value. So Java will parse this and say, oh, yes, this is a number. I get that. That makes sense. And beyond that, you might have numbers that are larger, right? So you might have numbers that are reaching in the millions. Let's say Jim bought about 1 billion apples because Jim is insane. That means that we need more binary bits to store the larger numbers. And so it has the same uses as integers, but for larger numbers. So if your math is involving like 2 to the power of 48 and modulus, a few other things, whatever. If your calculations need a lot more space, then you're going to use these long values. And so same way as we made the int, we're just going to say long, and we're going to say big count. So another thing in Java is something that's called camel casing. So I'll very quickly explain that. Let's say I have a word, and let's say it's related to the robot. So let's say we have a robot driving system. Now, in code, you can't have spaces in variable names, so you can remove them, and it looks like this. But we want to find a neat way to format this. So this looks fine. This looks okay. But a way to format words in Java, especially when they get, so let's say controller interface, it gets really large. So a way to format it in Java is called camel case, where the first letter is lowercase and all the ones afterwards are capitalized. And this is just how it's formatted. If you are familiar with other languages, you'll notice that they have different styling methods. So Python has something that's called snake styling. It's like you put underscores and everything is in lowercase. But in Java, it's all about camel casing, so that's just one way of keeping your code clean and following code conventions. And so we make a big count, and we'll give this a value of, let's just say like one huge number. Is that too large? Okay, get rid of the zeros. There you go. Still too large. Oh wait, I think I have to do this. Oh, okay, yes. Forgot to mention that. Yeah, so if your number actually exceeds, so the way Java works is, it's pretty weird. And so if I have a number like this, just a number in and of itself, it's going to count that as an int. So it's going to read it, and it's going to say, yes, this is an int. It won't actually read the type of it if you're just writing the number. If it's a variable, then it does know the type. But if it's just a number, it doesn't know the type. So to signify that a number is a long number, we add an L at the end of it. So it just took the L. It just got longer. It just got bigger. And so this is to tell Java, oh, you're not supposed to read this as an int. You're supposed to read it as a long. Right? So you'll notice that if I get rid of it, it's going to say, this is too large to be an int. So if I add this, now it's a long. So it fits within the range. And so this is the time where I ask, any questions so far? Is this better than the last one? Is it still going too fast? Do you still not understand anything? Please. This is going great. I am good. Good to know you're good. Is the I case sensitive? Or the L? Yeah, the L is not case sensitive. But it's just if you add an L like this, it looks like a 1 sort of. So people like to use a capitalized L. It's just more code conventions. Does that make sense? What happens if you put L next to an int? That's an interesting question. I think it might typecast. Oh, it does. Okay, so that's another fancy word. Typecasting. So typecasting is basically how Java will process your number. So remember what I said about it processing larger numbers as an int? If it's converting something to something else, so if it's trying to convert a long to an int, if it fits within the ranges, then it will do that. So that's called typecasting. It's how you can change the type of value. But again, really dumb, really stupid way Java works. It's really weird. So I apologize for that. It turns into, no, it remains an int. So actually, I'll show you in the next slide because that'll explain a little bit more. So if you've been in, I think, computer engineering, they explained this, but this is just a very simple chart. It looks a bit confusing though. Here's how you can convert a binary, like a base 2 value, so the ones and zeros of an int, into an actual number. So here it turns into 2012 for some reason. And it brings up an interesting conjecture, which is that all numbers can be made up of the sum of unique powers of 2, which is actually true and really cool. But yeah, you can add these numbers up over here to make any number you want, and just uses it sort of like 2 to the power of whatever place it is, right? So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on and so forth. And so you multiply, if it's 1, you multiply it by 1. If it's 0, then you don't. And that's kind of how it converts the numbers, right? So for an integer, it's going to be 32 of these. So it'll have 32 of these ones and zeros. For a long, it's going to be 64. So to turn the long into an integer, what Java will do is it'll just saw it off from the half, so it only gets 32 remaining. So that's kind of just how it converts it to an integer. That's how it typecasts. It just saws off the start of the number and prints it out. Is that good? Does that answer your question? Okay, sounds good. Yeah, so you guys can look at this chart and be amazed at how cool it is and how fun it is and how programming should be 100% be the focus of your entire life. Or you could just not, Let's continue. Next we have our second form of numbers, and these are decimals. So floats, these are essentially an integer split into two parts for the start and the end of the decimal, right? So if we go back to here, if we imagine, there we go. If we go back to here, if we imagine it as a 32, like a line of 32 ones and zeros, we just split it in the half. So the first 16 are for our actual number, and the last 16 are for our decimal number, right? And so that brings up some accuracy issues. Like, what if my decimal is like 1.33333333, like infinitely repeating, or some really huge pattern? And so that brings an issue there. And also, your number can't be very large when it's a float. And so floats are 32 bits. And so they're useful for anything that needs fractions or decimals. Like I said, like if you have a fraction of a field, or if you're calculating distance isn't always in perfect meters, despite what your math teachers will lead you to believe. So you will actually need to get decimals in there. So especially for distance in robotics, floats are a huge thing. And other things that need fractions or decimals. So let's say a percent of something, or blah, blah, blah. And doubles are basically floats, but with double the bits. Oh my god. And they're basically, yeah, exactly, like a float, but with double the bits. So that means that there can be more accuracy on the decimal side because it's 32 bits to work with, and also a higher number in general. So does that sound good so far? The float and double building blocks, primitives. Okay, sounds good. So we're gonna make our own floats. We're gonna make one for the length of, let's say, just the field. And we're going to say that this is 19.25 meters, right? So we can't add meters here, sadly. This is not math class, but we can just assume that this is, you know what, you could length in, oh no, that's capital. Length in meters. Do you guys spell meters like this or meters like this? I think it's the second one, but honestly, it just looks wrong. So I'm just going to do this. Yeah, so we can also make a double. So a double can be for larger ones. I think the double processing is actually the same as this one. You'll have to quote me on that. I'll actually try it out. So we're going to say that this is width. It's a very wide field, I guess. And we're going to say that this is like some huge number with some other huge number attached on the back. So like a D. Yeah, it is D. Okay. I was about to say, yeah. So we just slap a D at the end to make it a double. Second, because Canada, yeah. Well, the thing is, I was brought up in America, so... sucks to suck. But yeah, so we have our width in meters and our length in meters, and we just slap a D at the end to make it a double value. Everything good so far in terms of understanding the primitives and the building blocks of our code? Made a few variables. It looks pretty cool. With no D and it accepted it. It might. I have no idea. It might be the first part that needs to be that if it's too. Oh, wait, whoops! I started adding numbers there. If this is too large, then it might not process as an integer. Who knows? Oh, you might be right. I don't know. Java's a funky language. Oh yeah, it still works now. That's so weird. Whatever. You know, we can see how it works. Regardless, I'll just keep the D on there for now. And so yeah, we've made our building blocks. I'm assuming you guys are okay with it. You can look back at the recording if you're not okay with it. I hope you are though. And let's move on to machines. Again, more confusion. I love confusion. I love confusing you guys. Have I said that before? So strings. Let's talk about strings. So strings are a little bit different. Notice how all of these are in lowercase. That's very important to keep in mind. Strings are actually a little bit different, and they are also color different. So they're not just a building block. It has functions within itself that can use the building blocks that it has to perform different actions. ToString is also another one, but I'll talk about that after we make our first string. So I'm just going to add a little spacer in between just so that we can make the distinction. And we're going to make a string. So string is a capital. It's a capital S. And so we're going to give an ID to this. And notice how it's not also in blue, and that's because it's not built into Java. It's actually, I mean, it is built into Java, but it actually comes in as an object and not as a building block. So it comes in as a machine, not a building block, and that's why it's different. Okay, so we're going to give it an ID, and we're just going to say that this is the name of the robot, right? So the ID is name. And so to make a string, just how we encapsulated the char within the quotes, we actually use double quotes here, so that's how you know the difference. A char is only one quote, and a string is double quotes. And that means that you can add as much stuff as you want within strings. It just can't extend lines. That's going to be a bit of an issue. So you need to make sure that there's an ending. Pretty sure you can do it with the backslash. I don't remember though. Regardless, we're going to give a name to our program, and we're going to call this Pain. That's a great name. Shout out to the Naruto fans out there. Ikido Sennin. But we're just going to call it pain for now. And so that's the name of our program. And now that we have a name, we're going to look at a few of the functions that are in our name function, or in our name machine. So the difference is this is a building block and this is a machine. And so if I try to do a live dot something, nothing will pop up because it's just a building block. The building block doesn't have any mechanisms on the inside that can do anything, but the name is a machine. So if I do name dot, I can do a lot of things because there are mechanisms on the inside of the machine that can use the building blocks to sort of move around. So I think I have a diagram on the next one that makes it easier. Yeah, okay. And so don't mind the top part, but it's kind of like if you imagine those fancy Lego Technic parts, they're a lot more technical and they move around and have machines compared to just Lego blocks, right? So these can actually move around and do stuff with the blocks that they have attached, but these are just blocks. They can't do anything. So it's the same kind of logic here. And so we can actually look at the functions that are present here. So some of these you guys won't understand at all. Some of them are pretty obvious, I hope. So there's isEmpty. So isEmpty will return a Boolean. So this ending is basically saying what it will return. So after the colon, it's going to say it's going to return a Boolean. And so see, it's using blocks. It's building blocks on the inside and outputting them so that we can see them and use them. So we can do isEmpty, and this is going to say Boolean fake name. So we can check if our name is fake, and we're just going to say that that is name.isEmpty. Right? And so we can use that throughout our code. Does that make sense? Oh, are you confused? About the mechanism part? Sorry. I'll try to make it easier. So basically, our name is, like, think of it as sort of like that advanced Lego machine. So you can connect the Lego blocks to sort of like a robot, like a Lego machine. And within that robot, it can move around the blocks. It can change what's on the inside of them, can move them around, put them in different places. And so the way that you can do this is by calling back instructions within the mechanism, right? So if you imagine like a typewriter and you press one button, it's going to do a mechanism on the inside. It's going to move around, select the tile, and then press the tile on the paper. It's going to do the same thing here. All these have certain instructions, and we're going to call an instruction to do something with it. So these are multiple different mechanisms on the inside of it where we can sort of do something and find out how it works. So there's, I think, 2 uppercase. Yes, this one's a good one. So 2 uppercase will essentially turn our string to all of its uppercase characters. Is it a string name equals that? Did you name your string something differently? It is called test. Yeah, then you have to do test dot. So the way that it works is you need to call the name of the machine. So the machine, like let's say I have multiple typewriters and I want to fix one typewriter. I need to call that one typewriter. I don't want to fix all of them. That's a lot of effort. And not a lot of people want to do that. So we have to call either the name of the class or the name of the machine itself, right? So the class is the string thing. Again, I haven't gotten into classes, so don't worry about it. Just we need to call the name of the machine, which is going to be the ID of it. Okay? Does that make sense? Oh, name. Oh, okay. That might just be your IntelliSense freaking out. It's just 2 uppercase like this. You can type it out. If it doesn't pop up, just try refreshing your REPL.it tab. It might work a bit better. Who knows? Okay, so that's a thing. It's pretty cool and it's pretty important. So we will be using that. Let's go back to the toString thing. So all of our primitive types actually have their own machines that sort of work around the building blocks, right? So you can imagine it as the machine sort of covers the building. So it only works with these building blocks and does unique things with them. So for each single one of them, if we have Boolean and we just put it in capital, we'll see that that is a class. And so with the Boolean, we can do many things. So it has many mechanisms on the inside. And there's also one called toString. And so toString exists, or should exist, in every single machine. And it will turn that, that machine into a string. So it'll make a representation of the machine as a string. And that's really important. So boolean.toString will turn any Boolean value into a string of itself. So this will actually result in false, a string that looks like this. Right? And there's one for double as well. So if we do double.toString, we'll see that also exists. And we can do width in meters, And we'll see that this actually returns, whatever this is within quotes. So it just kind of turns your object into a string so that it can be used somewhere within your code. So all good machines should have a .toString function, and it's crucial because it lets us get a readable sense of what it is, right? So if I just look at a machine, I'm very confused. Let's say I go to a museum and I just look at some random machine from the 1860s. I am very confused. What is this supposed to do? Then I read the text under it, and it's like, this is a machine. It does blah, blah, blah. That description gives us a lot more information, which is why we use this .toString to give a description of what the machine has and what it does. So that's why we always want to keep a .toString. Everything makes sense so far? You have to go, okay. Sounds good. Everything makes sense so far for everyone else who is not leaving? If you have any questions, feel free to let me know, because I'm very open to answering them. That's why these are longer than the recording times. The recording time of this would be much shorter, but we have these meetings that you guys can ask questions and I can answer, and if there are any shortcomings in my presentation, then I can sort of cover them and make sure it works good. So, okay, it's good. Sounds good. Okay, we have our string machine and we have our other things explained. So, machines are built up of specific mechanisms and instructions along with building blocks. So machines have building blocks and everything. They're like big, right? That's why they're bigger than just the building blocks. And that's why we don't want a lot of machines, because they use up a lot of space, which is a bummer. Next we have a few, it's a little bit confusing. Okay, yeah, there we go. So it's a little bit confusing, but we have our terminal. So our terminal is this bottom guy over here. We actually haven't touched it yet. On your REPL.it, it says console or shell, either one of them. They're both, it's basically our terminal. And so in the terminal, it's how we interact with, it's how our code, it's one way that our code can interact with us. And it's through the terminal, because the code will run in the terminal and it can output information and input information from the terminal itself. So the output machine is actually a good machine in and of itself. So there are a few functions that we can use that will work to send strings to the terminal. So it'll send a string to the terminal and it'll show us. So it'll output the information of the string, which is great, because remember what I said about the description? We can essentially use a .toString function on any object and it'll give us a little bit of information on it, which is great news. And we will work directly with the output machine because it's easy to use. Next, we have an input machine. So we actually have to use another machine to interact with the input machine, and because the input machine is really hard to use. It actually gives you information in something that's called hexadecimal bytes. So the information will look something like, I think, 0xF33, and you're supposed to process that. So it's just really confusing. And so we're actually going to use another machine on top of it to understand how it works. So it's like, if you imagine, have you ever seen those videos of the robots that play the piano? The piano is a machine in and of itself, so we're adding a machine on top of the machine to make it easier to use. So we actually don't have to play the piano. Does that make sense? Yes. Okay, we have one yes so far. Yeah, okay, sounds good. So this other machine is known as the scanner, which is a really intimidating name, but don't worry. So let's get into using our input-output. Typically in a computer, you'll notice that there are terms called I/O. So say, oh yeah, this is my I/O panel, or oh yeah, your I/O sucks, or yeah, this is my BIOS. So basic input-output system, that's what BIOS stands for, which is really cool. So input-output is used really frequently within our computer terminology, and it's the basis of all programming because, everything, we need to give it information somehow, and then it'll output the results of what the algorithm does. That's how all code works. So let's get started with inputting and outputting. So to get our scanner, we actually have to import it from somewhere else. So we're bringing in a machine from somewhere else. We're not designing it by ourselves. Because again, we don't want to work with those bits anymore. So to import something, you use the import keyword. Thank you, Java, for being at least somewhat easy to explain. So the import keyword is just that, import in lowercase. And then we're going to get our scanner. So it comes from a library called java.util.scanner. And so this is a little bit confusing, but it's essentially saying, so Java is a library of inbuilt Java functions. Util is basically utility machines, and scanner is the machine that we're looking for. So it's going to look in the Java folder of machines. It's going to find the utility section where there are all the utility machines, and it's going to find the scanner machine. And then it's going to import it from there. Does that make sense? I'm going to drink water while you guys say yes or no, or don't say anything because you're too nervous to say no and whatever. And maybe is very vague. It's a yes or no question, my friend. Can you repeat that? Yeah, sure. So we're going to be using the import keyword or the import thing in Java to get our machine from somewhere else because we don't want to make the machine ourselves. Someone has already made the machine and we're just taking it from them, right? And so to do that, it's pretty simple. We're going to use the import keyword. So it's going to import the machine from somewhere else, right? So I hope you guys know what import means. It's like, bring stuff in. So imports, exports, whatever. The thing is, we're going to bring it in, and where are we going to bring it in from? And that's what we're writing over here. So Java is basically like a warehouse. Oh my god, that's going to bring back trauma. Java is essentially a place and has a ton of machines on the inside. And so we're going to go into Java, and then we're going to look for a section called util. That's what this dot is for. So the main place is Java, and we're going to go in a section, and that's going to be called the utility section. So that's what util is for. And then in the utility section, we're going to look for a machine with the ID of scanner. Once we find that machine, we're going to import it and bring it into our code. Does that make sense? Terminology for importing? It's just called importing. This would be packages and sub-packages. That would be the actual, I guess, terminology for it, but whatever. I digress. It's honestly easier to think of it this way. Okay, so now that we have brought in our scanner, yay, we can actually make a scanner. So this is kind of like the design for a scanner. Oh no, I'm bringing back the trauma. So this over here is the design for a scanner. So every time we want to make or every time we make anything in Java, let's say this Boolean, we're basically saying that Boolean is the design of the Lego block, right? So remember when I said the Boolean is like the 1x1 Lego block, and the char is like a bigger one, and then the int is an even bigger one. We basically know what they look like. We know what the Lego blocks look like. So we'll take their design and we'll make a copy of it, and we'll give it an ID, and then we'll put it in whatever our code goes, right? Wherever our code goes. And so it's the same thing with the string over here. We're basically taking the design of a string machine, making our own, and then we're adding our own blocks into it, which are these characters. So P-A-I-N, every single individual character. I think I lost a few people. Did I lose you guys? Can you import all of Java? Yeah, so to import multiple things, you have to do the asterisk. So it's like this, and that'll import everything from Java, but that's a very hefty import, and I wouldn't suggest it. Also makes your code a lot slower, so not a good thing. Yeah, efficiency. So let's get back. Yeah, so we can actually use the we will use the scanner design to make our own scanner, and we're going to give that an ID. So to do that, we're going to say scanner, and we're going to give it an ID, and we're just going to call it scanner, right, in lowercase, because our naming sense is 10 out of 10. And then we're going to say equals, and there's no easy way to make a scanner. So over here in the building blocks, we just use these sort of terminology. So there's false, there's this over here, and for numbers, but there's no easy way to make a scanner object. And so to make a new scanner machine, we're going to use exactly that, new. So we're going to say new, and now we're going to make our scanner, right? And so now it's basically saying scanner. Oh, I should name this something else. So scanner with the ID of, we'll call this input. Input, there we go. So scanner with an ID of input is a new scanner. So we're going to make a new scanner out of the design of what we pulled from this Java machine factory. Does that make sense? I don't want to lose you guys. Please don't lose me. Come on. You could lose and just say something about it. All good? What's a scanner? So a scanner is basically what we're going to be using to interact with our input, and it's going to give us, it's going to let us work with the terminal input and get some information from it. Okay, now that we know what a scanner is and sort of how to use it, we're going to, before we do that, we're just going to keep this on the side for now. We actually want to output our current information, so I think outputting is a lot easier. So to output, we just do system. So system is essentially our terminal system. So it's like the system that we're running on. System.out is what is like the output. So in terms of looking at it in a machine standpoint, system is like a huge complex machine. Out is just one part of this machine that we're going to connect to. And from here, we're going to use a mechanism called print, ln. or just print. I think print would work better. And so from here, we're going to print out value. And so let's print out name. So we're going to print out our name. And now, if we run our code, which don't do it over there. Oh, actually, compiling our code is going to be a new thing. Let me explain the other one before we compile our code. So there's actually another one, and this is called println. And the only difference is println will add a new line at the end of it, and I'll show you exactly what that means. So to run your code, you can press this run button over here. That should work. The run button should work. And you'll see that it does this javac command. I'll show you guys how to do it yourself. Oh, there's an error. Lossy conversion from double to float. Oh, so you actually need the F over here, and you don't need the D over here. That's interesting. The more you know. So now it'll run, and it'll print out our name, which is Pain. But notice how now this is over here, and it looks really ugly, and there's no line after. So to fix that, we use println like this. And so with println, if we run our code again, we'll see that it works. So just let me know if your guys' thing is like breaking. Yeah, it's the middleman. And it'll print Pain, and now it's on a new line. So life is good, everything good, world good, everything is great. Okay, I think we've gotten that working. So now we're going to actually get input from it, right? So let's make a name entering, or let's make a how old will you be in 5 years calculator, because that's so difficult. I don't know how old I'll be in 5 years. God forbid I have to calculate that. So let's get started. And this is going to be a little bit advanced, so I apologize for anyone who has any questions, but we'll get started. So first we need to save our int age, right? Oh no, first we need to get int age, right? And so this is going to be our age, and we're not going to give it a value yet. But before we do that, we need to make sure we're able to get input from the user. So we're going to make a scanner machine to get input from the user. And so to make a scanner machine, it's scanner equals, or we're going to give it a name. We're going to call it input. So we're making a machine of the type scanner, and we're giving it an ID input. And we're going to say this is a new scanner, so new scanner, and we're going to give it, there we go. And on the inside of these brackets, we need to know where it's getting this information from. So scanner needs to have some information to actually make a machine. And this information is going to be, where am I getting this text from? So you can actually get text from files. So you can do a file name.txt or something, and you can get information from the files. But we don't want to get information from the files, we want to get information from the terminal. And so to do that, what's the opposite of out? So in, exactly. So if we did system.out to send information outwards, we just have to do system.in to send information inwards. Oh my god, we did it. Wow, it makes sense somewhat. And so we're going to give scanner that information, and we're going to say, yeah, you're going to get information from here, and you're going to give it to us, and this machine is going to work, and it's going to give us this information from the terminal. Does that make sense so far? Might have lost you? I don't know. I'm trying to not lose you. Okay, I'm gonna say that hopefully makes sense. I don't know if it does, but I'm gonna hope you guys are good with it. Can you wait one more second? My REPL died, so I'm a bit behind. Ah, that's a bummer. I'll copy my. Can I see your code? Yeah, sure. I'll copy it actually, and I'll put it in the chat if you want to. There you go. That should be helpful. Okay, so I'm going to assume that you guys are good for now, so you understand how the scanner works. I hope you do. If you don't, then just let me know, and I will try to explain it in a better way. Okay, now that we have our scanner machine, let's make use of our machine. So let's see what we can actually do with our machine. So we can do input dot, and REPL dot will give us stuff that we can do. So close, okay, that's interesting. Equals, okay. Delimiter, what's that? Find all, find in line, find within horizon. Oh my god, this is really complicated. Has next, okay, that's a Boolean. So maybe that's like if it checks if it has next thing in the input, who knows. Has next int, does it have another int in the input, right? So you can like somewhat make sense of this. Next will return the next something, next string, who knows what that means. Next blah blah blah. Oh, if you actually move down here, you'll see next Boolean, that's good. Next byte, that's good. Next double, next float, next int, that's exactly what we need. We need a int from the input. We need an int from the user, so we're going to use this function. And we see that it actually returns an integer, right? So if you hover over it, it'll say int. and that means it's going to return an integer. So we're going to say int age equals this. And then now that we have, so are you guys following so far? Do you get the logical sense of how I went from input to getting next int from the input? Okay, sounds good. If it doesn't make sense, again, just let me know. Okay, so we're getting our age from the next int in our input. And now we want to output our age plus 5, right? So .println, and we want to put in our age plus 5. Pretty simple. So now if we run it, we will see that it totally breaks apart and dies. Oh no, hopefully it should work. Okay, it's not printing anything. Maybe it's waiting for me to enter in my age. I wonder how old I am. I am actually 16. So I add it. Oh my god, in 5 years I'll be 21 years old. I actually had no idea, guys. This is like such a reveal to me. I'm like shocked. I need a few moments to process this and to drink water. So if you have any questions, feel free to formulate them now. I'm going to be drinking some water. I know, right? Who knew that I'd be 21 in 5 years? That's actually surprising. Okay, anyways, it's kind of complicated because I don't know, like, the program just stopped for a second. I didn't know what I was supposed to be doing. So to make it easier for the user to, use, we can actually output some information before using, just to sort of prompt them. And so what I mean by that is we can do system.out.print, and here we're going to ask, what is, or how old are you? Not what is your age. It's so weird. How old are you? Right? So now we're asking the user, how old are you? And let's do println, because I said we should use println. And so now it's going to process this, and it's going to say, how old are you? I am 16. Thanks for telling me. And 21. What does 21 mean? I don't know. You don't know. Nobody knows. If they read the code, they'd know, but I don't know. So this is actually pretty weird. I don't like this because the 16 is on the next line. So I'm actually going to change this. I'm going to add a colon here, and I'm going to change this to print like this. And so if you run it right now, it's going to look a little bit different. And you'll understand why exactly now. How old are you? I am 16. You see, it looks much cleaner like this. So do you guys understand how I went from the... Yeah, so scanner constantly watches the terminal. So once you press the enter button, it's going to read the next line, and it's going to process it, and it's going to say, oh, are there any integers in this line? Yes, no. If there is, it's going to send it as the next integer that it gets. Yeah, okay, so does the logical sense of how I went from println to print and how I did this make sense? Sure. Okay, thank you, Rohan. That's a really loose sure. I'm gonna hope it does. Basically, we did print just so that it wouldn't do it on a new line, because if I did println and it's on a new line, it looks really weird. I'll show you. If I did it like this, it's going to print that out first, and it's just run faster, man. Why are you so slow? Yeah, it's going to be on the next line. So why is 16 here, and why is it not up there? It should be up there. So that's why I put it as just print, not println, so there'd be no line after it. Okay, perfect. Now, I don't know what 21 means, and the user probably doesn't either. So we're going to tell that to the user. And there are two ways that we can do this. There's the easy way and a hard way. Do you guys want to do it the easy way or the hard way? Great. You're really in it to suffer, aren't you? Okay, let's do it the hard way then. I'll also explain the easy way afterwards, just so that you can regret everything and just say, okay. So here we're going to say, you will be, and then we want to enter in how old they will be in however many years, so we can just do age plus 5. And now you'll do a space, and you'll say, in 5 years. Right, so this makes sense. You will be, and then I add age plus 5 in 5 years. So let's try to run this. This should work, right? Right? I'm totally not making a huge error that Java will scream at me for and break apart and die. There's no way I could ever do that. Oh, it actually compiled. That's funny. You'll be 165 in 5 years. Wow, really? I can't believe it. I never knew I'll be 165 in 5 years. So do you guys notice where the issue is? Okay, sounds good. Do you guys notice where the issue is? The issue comes in the fact that it's adding 16 as a string to 5. So 16 plus 5, if 16 is a string, would be 165. which is not how old I will be in 5 years and not what we want to do. So to change it, we'll actually use the integer machine. And so if you guys remember, that is the integer guy over here. And so so every single thing has a .toString method, if you remember that. So integer is a machine, and it takes int building blocks and it'll turn it into a string. So we can take an int, which is age plus 5, and turn that into a string. And so now if we try to run our code, we will see that it, hopefully, will run and not break apart. You will be 21 in 5 years. Wow, thank you for letting me know. Does that make sense to you guys? Couldn't you just surround it with brackets? No, it'll still add it as a string, I think. Actually, let me try that. Let's try that. I don't think it does. I think you need to get the string value of it, because it needs to process that first. It needs to turn it into a string, and we need to use the integer machine for that. So if I do 16, oh, it actually does work. You know, Java got smarter over the years. I actually don't like it. I used to do this as a lesson before, just kind of like, yeah, Java's stupid because you can do this and it doesn't work, but this works and I hate it. Screw you, Java. Not supposed to work. And the easier way that I wanted to sort of mention, not easy, but it's just less understanding that you have to do, will be you will be, and you just set this as system.out. Okay, let's just set these, let's show you what happens if you do it like this. And if you do system.out.println and then age plus 5, and then system.out, no, not ut.println in 5 years. Do you know, I'm adding the spaces so that it's spaced out. I hope that makes sense. So if I try to do this, then it'll look a little bit weird. Just let it compile. It'll be like, you will be in 5 years. And it's just like, what? This doesn't make sense. And so that's why we want to change these to just prints, so it's all on the same line, except for the last one, so that it goes on a different line. This is the quote-unquote easy way of doing it.